introduced almost all of these concepts. We're just going to go through some examples, and I'll explain how you can approach these, especially those that come from the SAT, because sometimes there are specific strategies for SAT questions that don't always apply to everyday math class questions. All right, so for the first concept here of slope, when you're dealing with slope, remember there's three different ways that you'll tend to find slopes on this. One, you can count the rise over run of a graph. Okay. Two, you can use the calculation method of taking the difference of the y's over the difference of the corresponding x's. Okay. And then sometimes, again, you might see it as the change in y's over the change in x's. You can think of it as those ways. And then the last way would be that you can solve an equation for y. And by doing that and putting it into the slope-intercept form, what you can then do is you can find the slope by just taking the coefficient of x. So those are the three main ways that you're going to see calculating or finding the slope. Okay, so what I want you to do is try just this first problem right here. See if you can find the slope. All right, so I'm going to talk through this first problem here. You recognize that it gives you two ordered pair, so that's the method where you can just calculate using the formula. And so if we take our slope is equal to the difference of the y's, so 10 minus a negative 5, there's your two y coordinates. And we set that over the difference of their corresponding x's. So if we take the difference between the x's, 5 minus 1. Remember, you can enter your answer as a calculation, so that could be all you entered. However, you can also simplify what you have. 10 plus 5 is 15 over 5 minus 1, which is 4. So you can enter your answer as a calculation. You can enter it as the simplified fraction form. Or if you look, this will demonstrate, or this will display the decimal value, calculated value of that. So you could also just enter that calculation or the calculated value as well. So all of those would be acceptable forms for that answer. Okay, I'm just going to go through the next question is the same type of question. Here they give you the x and the y intercepts, but you can solve for the slope the same way, just by calculating. So I'm going to, even though you didn't do this one, I'll just take really quickly the difference of my y's, so 90 over 7 minus 0, over the difference of the corresponding x's, 0 minus a negative 5. Subtracting is equivalent to adding the opposite. And so what you wind up with in a problem like this is 90 over 7 divided by 5. And remember, dividing is equivalent to multiplying by the reciprocal. So if we multiplied by the reciprocal of 5, which is 1/5, you can simplify what you have. 5 goes into 90 18 times. So you get 18 over 7 would be your answer. And those would be the two methods where you're just calculating. Okay, if you look at this next problem up here, here's one where you can take your equation and solve. So that would be this last method that we talked about in the boxed area. And so you would distribute your number, the 1/5. So you get 28/5 x plus 24/5, all plus. Now, instead of writing this 8x, instead of writing it as 8x, think about it in terms of its fraction form. Because you have your coefficient of x is in terms of fifths. So let's write 8x in terms of fifths also. So 8x is how many fifths? 40/5, right? And so what that allows you to do is it allows you to combine your terms here, 68/5 x plus 24/5. And so that is your slope, the coefficient of x. All right, the last question here I just want to talk through, kind of talk you through. And this is probably the one that's the most confusing. It's just the way that it's set up. It's not any one of those three, although it does kind of fit this pattern right here. By definition, the slope is the change in, that's delta y over delta x, means the change in y's over the change in x's. It doesn't necessarily have to be a calculation because if we're looking at how, like as x's go up, and each of these is moving up by 2, right? So we see that the change in x's is happening by +2. Well, we can also see the change in y's by looking at these. And the easiest ones to see is, what do you do to go from n plus 97 to n? Are you increasing or decreasing? Decreasing by what? 97, right? So each time you have that increment, you're going, you can calculate your slope by taking the difference, the change in y's, you're going down 97, as your change in x's is happening where you're going up by 2. And so that is your overall slope. And so you would get your answer of negative 97 halves for that. Okay, and so even though it doesn't fall into either of those specifically, you can kind of fit it into that rise over run or change of y's over change of x. All right, this next slide is a review of what we talked about just the last class, and that is when you're dealing with a line whose slope is a over b, and you're comparing that to the slope of a parallel line and a perpendicular line. Well, parallel lines have slopes that are what? Equal. So the slope of a parallel line is going to be equal, and perpendicular lines have slopes that are opposite and reciprocal, right? So this is the relationship. If you start with the slope of a over b, the parallel line will be the same. Perpendicular line will be negative b over a. And so use that information to answer these two questions here for me, please. Right, so when we look at this first one, the first one's very straightforward, right? Here is our slope given, so that means a line parallel will have a slope of what? Same thing, right? And the slope of a perpendicular is going to have opposite, so positive, flip the fraction, 14 over 25. So those would be your two answers for this first question. The second question, in order to answer this, again, you're finding the slope of a line perpendicular to the given line is, since it gives us an equation, we want to solve for y, put it into slope-intercept form. So we subtract 12x from both sides, leave the constant where it is, leave the 4y where it is, and then divide each individual term by 4. That gives you a negative 3x plus 3/4. So that means your slope is negative 3. Therefore, the slope of the perpendicular is going to be the opposite, positive, reciprocal, 1/3. And so that would be your answer, 1/3 here. All right, so again, relatively straightforward. All right, the next slide, again, we have talked about equations of lines already. Maybe this one, I do want to, again, kind of specify what happens when you're dealing with equations or dealing with problems on the SAT that might be a little bit different than what you would normally see. Okay, so if you're given the slope and the y-intercept, the best form to use would be the slope-intercept form, okay, where you have, again, this slope and the y-intercept. You can just plug it right into that form. If you're given a point and a slope, then the best form that you might use would be the point-slope form, which has the following pattern or equation, where you have the xy coordinate of a point plus you have the slope here. Okay, and so based on whichever piece of information is provided, you can choose one of those methods. So again, if you look at these equations down below, or the problems down below, see if you can find the equation for each of those based on working with slope-intercept form or point-slope form. One of the more unique things about SAT questions is that sometimes you just need to be able to identify which is the answer. And you don't have to know how to solve it. And you just need to be able to find which of these is the answer. Okay, and so one of the very first strategies for every math question on the SAT is scan your answer choices. So when you scan these answer choices, you see right away that you're dealing with a linear equation. Okay, and really from each of these, it's a slope-intercept form, so you see your slope is either going to be 1/8 or negative 1/8. and you see that your y-intercept is either going to be plus or minus 18. Okay, so right here it tells you you have a slope of 1/8. So that means that these last two choices cannot be correct. They have negative 1/8 as the slope. So the only other thing that you need to do is determine which one of these has the y-intercept of 18. Notice that point, this ordered pair, is given as a y-intercept. The y-intercept is the value of y when x is 0. So we see that 18 is the y-intercept. So you should be able to either eliminate this choice or identify that the first one is the correct answer. Okay. The second problem, same idea. When you scan the answer choices, you see everything's written in slope-intercept form. Your slope is either 3, negative 1/4, or 4. And your y-intercept is either negative 18 or negative 69 over 4. Okay, so when we look at our problem, we see that it tells you that you have a slope of negative 1/4. So immediately you can eliminate the first and third options. And now it's just a matter of finding what remains. Now, let me show you a couple ways to do that. Specific to the SAT, the best way to find the answer, in my opinion, is to just test the given point. You have this x and y coordinate. See in which of these equations is that true. So negative 18 equal to negative 1/4 times the x value 3 minus 18, or is it negative 18 is equal to negative 1/4 times the x value 3 minus 69 over 4. Well, when you're looking at these here, as you start to solve for this, add 18 to both sides, you get 0 is equal to negative 3/4. Is that a true statement? No. So right away you have your answer. Remember, on the SAT, you don't have to solve it. You just have to find what is the answer. Does that make sense, the difference between those? So here we never solved this question, and we know that this is the right answer. And now you can always confirm it. So if we test this right here and test, we get negative 3/4 minus 69/4 is negative 72/4, which is negative 18. So it is true. We test it and find out that it is true. Okay, and so you can still solve it, but as long as you get your answer, you're good. Now, let me go back, because a big part of this is like solving based on what you see. So if you look at the problem itself, you have a point and you have a slope. So that is encouraging you to use point-slope form to solve this, which you can do. So if you use point-slope form in this, y minus the given y, negative 18, is equal to our slope times x minus our given x3. What you can do here is you can just solve this equation, and that would be your answer. So subtracting is equivalent to adding the opposite. If we distribute through, we get y plus 18 is equal to negative 1/4 x plus 3/4. Subtract 18 from both sides. Well, subtracting 18 is like subtracting 72/4 if you put it in terms of the same denominator. And when you simplify, you get your answer here to be the same problem, or the same expression that, or equation that we answered correctly with. So you could do it either way. But if you are going to follow sort of the rules of what the setup is giving you, it's giving you a point and a slope. Using point-slope form winds up being easy. All right. Next set of questions. I want you to, again, try finding the equations for these two problems. So again, if you stay consistent with the scan your answer choices first. So we see these are all slope-intercept form. It's a linear equation. Your slope is either 4, 1, 1/4, or negative 1. Okay? And then your y-intercept is either 5, negative 1/4, or positive 1/4. So when we look at our given points, first of all, the first thing that stands out about those equations is if you calculate your slope, you have your right answer, right? You don't even need to know anything else. All the slopes are different. So probably the easiest thing is to just go ahead and just calculate the slope. But if you notice that one of the points, 0, 5, that is the y-intercept. And so you know that your y-intercept has to be 5. So it's either going to be option 1 or option 3 from these equations. So our slope is either 4 or 1/4. Let's calculate the slope here. The slope, we take the difference of our y's, so 9 minus 5, over the difference of the corresponding x's, 1 minus 0. And so you get 4 over 1, which is a slope of 4. that would give you your answer choice A, or the first answer choice. For the second problem here, similar type of thing. You look at your answer choices. You see the slope is either plus or minus 2 or plus or minus 1. Your y-intercept is -4 every time, so that really doesn't distinguish anything, but the slope does. So all that you need to do is find your slope. And the best way to find the slope with a graph is to count. So if we find any 2 points, we count down from -2 to -4 is down 2 over +2. So -2 over +2 gives us a slope that is -1. So here is your answer choice for this problem. Okay. So hopefully you can see by scanning answer choices, you can often narrow down which ones even stand a chance of being correct, and then that will save you a little bit of time. All right, the next slide here, we did questions like this on the last homework assignment, so I'm not going to go over this one again. But I do want to talk through a couple of these story problems here on how you would use the linear forms to set up and solve for equations. All right, so let's take a look at this problem here. And again, we're just going to kind of walk through these together as we go through. So you see that there's no answer choices to scan. So you have this 390-mile trip. That means that your total is going to be 390. You see that there's an average speed of 60 miles per hour for X hours. So 60 times X gives you the distance that's covered in that portion of the trip. And then driving at an average speed of 45 miles per hour for the remaining Y. So we add 45Y becomes the second part of this trip. And that gives the total distance traveled at 45 miles per hour. So the first thing that you would think of is coming up with this equation to relate the information provided. And then the second part to this is if it wants you to evaluate when X is 2, that's what you would do. Substitute that in, solve for what you have. And when you do that, move your constants to one side, divide by 45, and that will give you your total Y value, which is 6 for that question. All right, notice in this second equation, or this second problem here, they provide the equation for you, and when you scan the answer choices, what you see is you just need to be able to interpret what part means what. Okay? And you can see from the answer choices, they all involve 8. So basically, you want to determine what does the 8 represent in that equation. So I want you just to kind of read through the problem and identify what you think 8 represents in this problem, please. One of the nice things about approaching SAT math questions with the idea of eliminating answer choices that don't make sense or that you can eliminate is even if you don't know how to solve the final answer, it narrows down the chance of you guessing correctly, or it improves your chances of guessing correctly. So on this, you scan the answer choices, you see you're interpreting what 8 represents, go into the equation. When you look at this here, you have 9 times X and 8 times Y. Well, when you look at this, X is the number of sides of figure A, so X represents A, and Y here is the number of sides of figure B, so Y represents B. So the very first thing that you can do is go in and eliminate. You know that 8 is associated with B, so you can eliminate these last 2 options because they are associated with figure A. And so now it's either going to be the number of sides of figure B. Well, the number of sides, here it says specifically, Y is the number of sides. That's not 8, that's the Y part of it. So we can eliminate that. And so our answer has to be the measure of each side just by process of elimination. All right, this last problem here, just really quickly before we get started, these should be P's here and this should be S's. So these are all the same. When you scan these answer choices, the same idea. You see that they're linear functions. okay, where your slope is either 13, 13 over 7, 7 over 13, 13 over 7. So you know that that's one of your slopes. And then your y-intercepts, you have 3 or 4 different values for y-intercepts. Okay, so when you are looking at this, you could eliminate this last choice, right? Because you see right here, since the x value is not 0, 35 is not the y-intercept. Okay, so that at least eliminates one of these. And so now you're left to find which of these is your slope. Once you find what the correct slope is, you're good. And so if we find the slope in a similar fashion that we did with the change in y over the change in x, we can find our answer. So the change in y's as you go from, again, just take the difference of our y's. So if you take 74 minus 35, that's the change that happens while the x's change from 42 minus 21. So if you calculate this, you get your answer. And now notice for these, or when we work through to calculate, we get 39 over 21. And that reduces to 3 goes into 21.7, 3 goes into 39.13. So there is our slope. Now, it's true that there's another equation that had 13 over 7 for a slope, but we eliminated that based on the y-intercept. And so you get your answer from that interpretation. So I do recommend for SAT math questions that you try to eliminate any answer choices. Scan the answer choices, eliminate any that are not correct, and that generally makes your finding your solution easier. All right, the last 2 questions. Again, this is hard to see because it kind of got cut off, but that's a 60 right there. I want you to see if you can answer these 2 questions. The one Right. So the problem with the graph, when you scan your answer choices, you see that 2 of them are slope-intercept form, the other 2 are standard form. And so when you're checking, you see that your y-intercept is 60, right? So that's your y-intercept. That means that you can eliminate these 2 slope-intercept forms because neither one of those is 60. It's 5 and 6, so you know those aren't the correct answer. So the next step for this would be either solve each of these equations for y, which is one possibility. So here, if we leave our 5y on one side, move the x's over, and divide by 5, do we get a y-intercept of 60? Y is equal to negative 6/5 x plus 60. Yes, we do. Now, we just need to verify that that doesn't happen on the last one. So if we isolate our y here, subtract 5x from both sides, and then divide by 6 to isolate our y, we get y is equal to negative 5/6 x plus here we get 50. So this identifies that the only possible solution would be that second equation. Right, the final problem, again, the wording it can be confusing, but if you just scan your answer choices, you see it's interpreting information, and you're either finding total number of trees or the average number of trees in either the residential area or in the park. So if we go back up and we find our equation, it's just a matter of identifying what represents what. Okay, so the x's and the y's are the two different variables. We are told here that we want to find what x represents. Okay, so 4 is associated with the park. 32 is associated with the residential area. And so right now, since we're finding what x is associated with the park. That means that we can eliminate the first and last choice, right? Those have to do with the residential areas. So we're either going to identify that x is the total number of trees in the park or it's the number of trees per hectare. When you look at this whole thing right here, this whole quantity 4 times x is the total number of trees in the park. So we can eliminate that. We just want what the X represents. And again, by process of elimination, that leaves the average number of trees per hectare.